you're not, you know what to do about that. All right, let's get our phones in the caddy. Are they all up there? Boys in the middle here, are all the phones in the caddy?
Yeah.
All right, so we're in our notes. I know that you're all excited. It's the end of the day. We got to focus. We got some important stuff to do. Evaluate exactly. We are on 5D on the back of page 43. We're going to evaluate exactly the tangent of negative 240. Now, when we draw our angles, we use labels starting here with 0, right? And 90, 180, and so on. But since that's negative, I'll go the other way. So this is negative 90, negative 180, negative 270. So negative 240 will be somewhere in between here, right? So I'm going to draw negative 240 right there. So this is my negative 240. So let's pause right there. Everybody good? Okay. So now we're going to drop a perpendicular. And remember, your triangle will always sit on the x-axis or hang from the x-axis. It's the butterfly bow tie triangles. So right there it is. Now, the angle that I need, it's called my reference angle. It's the key to the whole problem. That angle right there is from 180 to 240. So it will be 60. That's got to make sense, because if you screw up the angle, you're going to screw up your sides. Your answer will be wrong. Ronan?
Why did you do 180 and not 260?
Okay, I want you to look at where the triangle is. The triangle doesn't have anything to do with 270, does it? Nope.
Yeah.
So I'm using 180 and 240, the sides of the triangle. Okay, and in fact, Ronan, if you stop and think about it for a second, since all of my triangles look like this, I will never use 90 and I will never use 270 because my triangle isn't associated with those lines. Okay?
Yep.
All right, now, so what have I got here? A 30, 60, 90 triangle. And I have memorized that the 30, 60, 90 sides are 30 gets 1, 60 gets root 3, 90 gets 2.
Where you have to memorize those by?
They're on your sheet, Jake. You've had over a week. Come on.
Albert? Negative root.
Now, be careful. See this 1 right here? He's actually negative. Why is that 1 negative? Because he's to the left of the origin, right? Our triangle is in quadrant 2. If you aren't in quadrant 1, something will be negative. Okay? Quadrant 1, you don't have to worry about it, but every other quadrant, something will be negative. Okay? Now, I want tangent. This is your angle. Tangent is opposite over adjacent, so negative root 3. Right?
Yep. That's what I got.
Cosine 7 pi over 6. Okay, so listen to Elijah. He says, I don't know what's happening here. It's going to be a 30-degree angle. How does he know it's going to be a 30-degree angle? Because pi over 6 is 180 over 6 is 30. Now, it isn't 30, it's 7 times 30, which is 210. But Elijah, when I draw 210, this is 180, this is 210. How big's that angle right there?
30.
Yeah.
Oh, that's
Anytime your denominator is 6 pi over 6. Anytime, I don't know what your angle's gonna be, but the reference angle will always be 30 every time.
Negative
Okay, now that's 30. So this is 1, this is root 3, and this is 2. It's the
Negative
same
root 3.
triangle we had over here, just situated
Negative root
differently. Actually, they're both negative, aren't they? Hypotenuse, always positive. Okay, I want cosine. Cosine is adjacent over hypotenuse. So I got negative root 3 over 2. How about you?
So I got
That rhymed.
Yep, you just never know what's gonna come out of my mouth. Secant, 5 pi over 4. Alright, this is not gonna be a 30, because the denominator's 6. Anybody have an idea what the
45.
45? This is gonna be some form of a 45. Alright, well, where is the angle? 5 pi over 4 is 5 times 180 divided by 4. What is that? 225. So I'm gonna draw 225. And again, this is 180 and this is 225. So do you see the 45 growing out of that? Anytime the denominator is 4, your angle's gonna be some version of a 45.
Negative 1, negative 1.
So we've got 1, 1, root 2,
Negative.
and both of the ones are negative. Secant, okay, secant is reciprocal of cosine, so it's hypotenuse over adjacent. So root 2 over negative 1 or negative root 2. Now, everything was going along great. You guys were really doing great. And now I'm throwing you a curveball. Tell me why this is a curveball, Ronan.
It's not an angle.
It's not an angle. Well, it is an angle,
But it's like-
but it's not one of these slanted things, right?
Yeah.
When you go 90 degrees, aren't you right here? And remember, if you're gonna draw a triangle, it has to be one of these. That won't be possible to draw one of those triangles through that point. Does that make sense to you?
Yeah.
When your angle is on an axis, so there aren't very many, basically it's 90, 180, 270, 360, yeah.
Sure.
When it's on an axis, no triangle can be drawn. Instead, you draw a circle.
Oh.
Now, wait a minute. Let's think. I have no idea what that point is because I don't know the radius of my circle. You can make, let me be clear, you can make the radius anything you want it to be. Because of that, I always make it 1 because that's the easiest possible number. Now, you can make it 2, you can make it root 7, I don't care. It's not going to impact your answer. But I like to use what's called the unit circle, centered at the origin, radius of 1. Now, tell me about this point right here, if the radius is 1.
1, 0. Or 0, 1. 0,
0, 1. Would everyone agree with that?
Yeah.
So, in other words, x is 0 and y is 1 for that point. I don't know if you noticed or not on your green sheet. Get it out if you haven't looked at it. Where I said sine theta. David, are you okay, honey? You want to sit up for me? Are you sick? Well, sit up. Get out some paper. Put out your snacks on. All right. Where it says sine theta equals where it says sine theta equals opposite over hypotenuse.
Yeah.
I don't know, did you pay any attention? It says something else. What does it say? Y over R. These are called the circular definitions. The SOHCAHTOA is for the triangle, opposite hypotenuse. If you're in a circle, you need new definitions. So sine is Y over R. Well, wait a second. For us, that is simply going to be 1 over 1, which is 1. The sine of 90 is 1. Okay, Ronan?
Where'd you get the one for the Y?
Well, I made up the radius. And if the radius is 1, I'm going straight up 1, so my Y value would be 1. Think of a piece of graph there. I'm going up 1. All right, let's try the next one and see if you got this. Where did I put mine? Oh, here. Cosine pi. All right, where's pi? Well, first of all, what is pi? Pi radians is 180. And isn't 180 right here? Okay, it's on an axis, so I need a circle. I'm gonna let the radius be 1, because that's the easiest. What would be the coordinates of that point? There's the origin. You're going left
Negative
1.
1, 0.
Negative 1 comma 0. So x is negative 1, y is 0. And we want the cosine. Cosine is x over r. So negative 1 over 1. So the cosine is negative 1. Before we go any further, I know some of you are thinking, oh my gosh, this is more to memorize. You really already have it memorized. I want you to think about something. When we draw a butterfly bow tie, we call this the adjacent side, and this the opposite side, and this the hypotenuse, okay? But in reality, when I plot that point, I go over and up. So isn't this x?
Yeah.
And this is y? And if I drew a circle around here, that would be r. So when we say cosine is adjacent over hypotenuse, that's really saying it's x over r. So it's nothing new, it's just a different way of labeling it. Okay? All right, one more. Tangent 3 pi over 2. All right, figure out where is 3 pi over 2. Where is that? What is that? 3 pi over 2, what is it?
180.
No,
3 times
220.
it's 3 times 180 divided by 2.
275.
Oh, wait, no.
270?
270, yeah.
270?
Holy cow.
All right, those of you that are struggling, stop a minute. What's pi?
180.
180.
380.
Pi divided by 2 would be 90, and 90 times 3 is 270. Let's not overthink it, okay? Where's 270? Now it's positive 270. So it goes all the way around like this, right? There's 270. All right, if I make my radius 1, what is my x and y down here?
Y is negative 1. X is
0, negative 1? Now, let's see if you can figure this out without looking at your sheet. Tangent is opposite over adjacent, right? So that's going to be y over x. So y over x is actually undefined. If you have your calculator, get it out. Press tan 270. It's going to yell at you. exactly what it's gonna say, but it's going to not like it.
Domain error.
Domain error. Can't take the tangent of 270. Graphically, in a couple days, graphically, that's gonna have some implications. But for now, we just write undefined. Tangent to undefined. All right, I'd like you to try J with your partner. Secant negative pi over 2. Try that one with your partner, please. All right, how we doing? I got undefined. What did you get? You need to ask if you didn't.
Undefined.
Jake, are you paying attention?
I got it. I mean, you can see.
All right, cotangent, 780. Whoa, what about 780? Well,
At 6 degrees.
it's bigger than 360. And in fact, isn't it bigger than two 360s?
Yeah.
Because two 360s would be 720. So this is spin, and then go 60 degrees more. How did I get 60? I subtracted 360, subtracted 360. This is a coterminal angle. Remember from yesterday? We hadn't subtracted revolutions. I need to get this angle manageable. I don't need all those extra spins. Throw them out. 780 minus 720 is 60. So then I can draw 60. 60, guys, is not on an axis, so I'm back to a triangle. Does that make sense to everyone? 0 and 90 here. So my sides are root 3, 1, and 2. I'm in quadrant 1, so everything's positive. What's my cotangent?
We're three.
Watch it. Adjacent over opposite.
It's
So 1 over root 3, root 3 over 3.
Come on.
oh, it's opposite.
Now, if you want to skip SOHCAHTOA for the rest of your life, you can. Because you know that this is x and this is y, and cotangent is x over y. So you can do all your problems in terms of x's and y's if you want to. I personally still use SOHCAHTOA all the time. All right, last one, cosine 0. 0. Where's 0? Right here?
Right here.
On an axis, need a circle. What are the coordinates of that point?
0, 1, 0.
1, 0. What's cosine in terms of your circular definitions? Cosine is x over r.
So what?
So x over r will be 1 over 1 or 1.
Oh no.
Good? Wow, that's a lot. All right, now we're gonna move on to probably what's gonna be one of the hardest things
Oh god.
in this chapter.
How hard is it gonna be? I don't know.
I think you guys can manage it, but I think you're gonna have to really be open-minded and focused.
How's it not hard for you?
Okay. All right, here we go. I have an angle out there. I have an angle out there, and I know two things about it. I know that its cosine is 2/3, and I know that its tangent
It's less than here.
is negative. So think of this as negative, all right? Now, what is cosine? By definition, cosine has two definitions, adjacent over hypotenuse, and what's the other definition? X over R. So this is X over R. And what's tangent?
So, opposite line.
Okay, what's the other one?
Y
Y
over
over X. All right, we gotta figure out where we're gonna draw this picture. And these two things tell me, remember, R is always positive. R is the hypotenuse, and the hypotenuse is always positive. So if the cosine is 2/3, doesn't X also have to be positive? So X is positive. That's narrowed down now, I'm either here or here. That's where X's are positive. But the tangent is negative. Now, wait a second. Is anything negative up here?
Oh, it's just,
So your picture has got to be in quadrant 4. That's the hard part. Once you know what quadrant you're in, then it's pretty easy. So let's back up and make sure you followed all that. We know that 2/3 is a positive number. We know R has to be positive, so therefore X has to be positive. That happens over here. But tangent, which is Y over X, has to be negative. Nothing's negative up here, so I must be down here. Okay? And I know my adjacent and hypotenuse is 2/3. X, R, and you don't have to think of this as a circle, but you can, that's your radius, it's your hypotenuse. X over R, adjacent over hypotenuse, I don't care how you think about it. Now, what's this? Pythagorean theorem. So 2 squared plus y squared equals 3 squared. I'm trying to figure out what that is. So 4 plus y squared is 9. So I think Jake's right, I think this is a root 5. But because of where I am, it has to be a negative root 5. Remember, if you're not in quadrant 1, something's negative. And it's never the hypotenuse. I need to find the sine and the cotangent. That doesn't mean add them together, that means what are they? So I need to look at this triangle. What is the sine? The sine
Negative
is
root 5 over
negative root 5 over 3. And I need the cotangent, yep, which is
2 over negative root
x over y, adjacent over hypotenuse, 2 over negative root 5, or negative 2 root 5 over 5.
5. You have to like simplify that.
This is.
Oh, wait. Oh, I thought it said you had to add those two together.
No, yeah, no, we're not. It looks like that, but that's not what it means. It means finding both. All right, there's one more of these hard ones. Let's see if we can sort it out. You can do it.
It's not as hard as I thought it would be.
Sine is 1/5, and cosine is negative. All right, so let's stop. Think a minute. What's sine?
Y over R.
Y over R. So if that's a positive 1/5, doesn't that mean y has to be positive?
yeah.
Remember, r is always positive. So where is y positive?
The right side. Oh, wait, down, up.
Y is positive
First and
here and here,
Yeah.
so here and here.
Yep.
But the cosine is negative, so if these are my only two options, doesn't it have to be over here? Right?
Yep.
So my triangle is over here in quadrant 2.
Yep.
And the y over r, or opposite over hypotenuse, is 1/5. Pythagorean theorem now, carefully.
2√6.
1 squared plus x squared is 5 squared. X squared equals 24, 25 minus 1,
2√24.
Negative square root of
and I'm square rooting, so x has to equal 2√6,
Yeah.
the square root of 24. And be careful though, when I put that 2√6 up here, I gotta make sure I mark it negative because of where it is to the left. That will be the biggest mistake that's made. People will forget negatives. Pay attention to where you are. I want the secant and the tangent. So secant, reciprocal of cosine. Cosine is adjacent over hypotenuse, so this will be hypotenuse over adjacent,
Yep.
which is 5 over negative 2√6.
I think that's a number right there.
So we'll multiply only by the radical. So we have 5√6 over, those two make a 6, negative 12. That makes sense to you?
Yeah.
Sure? All right, lastly here, we want the same picture, we want the tangent.
1 over negative 2√6.
Tangent is 1 over negative 2√6. So we'll do the same thing. And get negative √6 over 12.
Yes.
You put the negative on the top or the bottom, doesn't make any difference. One of them's gotta be negative, put it wherever you're comfortable with it. Is that all right? Okay, number 7A, it'll blow your mind here. Yeah, I know. All right, here's my coordinate plane. Let's start with that. I want to find the angles whose cosine is negative 1/2. And by the way, since it says find all the values, that implies that there's going to be more than one answer. Okay? So let's start with what we know. Do you have any ideas? Do you have any thoughts?
No, never mind. That's adjacent over 25.
Okay, now wait. Let's think about something for a minute.
Never mind, 30.
If the cosine is negative, what does that tell me? If the cosine
X is negative.
X is negative. Cosine is X? If cosine's negative, X is negative. So whatever my angle ends up being, it's going to be in this quadrant or this quadrant because that's where X is negative. Okay? Now, these two triangles are exactly the same. So I'm not gonna label both of them. I'm only gonna label the top one. It doesn't matter which one you label, but they are exactly the same. So you don't need to do both. So -1 and 2. Here's your angle right here. -1 and 2. Is that okay? This has got to be √3. This is a special triangle. What angle is across from the root 3? So this angle right here is a 60, so is this one. They're equal. The answer to the question, though, isn't 60, because this angle is in quadrant 2. So that's the answer. How big is that angle? What? 120. How did you get 120, Sam? You're exactly right. That's 120 degrees. How did you get that?
180 minus 60.
Exactly. This is 180. And I stopped before I got to 180. I stopped 60 before I got to 180. So it's 120. Now, the other answer is this red one. All the way around to here. So it's going past 180. How much past 180? 60. So what's that one? 240. And there are your two answers in degrees. We haven't done them in radians yet, we've done them in degrees. And you know what? You guys have been amazing. We packed a lot of stuff, so I'm stopping. I'm stopping. And
You're still right.
we'll pick up here.
I think you had to stop. You worked on it.
I could have kept going.